Okay, so now that we've talked about what I is, now we're going to be doing a couple different operations with I. So the first thing that I want to bring up is I is actually a lot like when you have X or any kind of variable, Y, A, B, that kind of thing. So if I were to ask you what 3x plus 4x is, you would say it's 7x. So as you can see, since these two are the same, you're able just to add these two and you'll see that we have 3x plus 4x's is 7x's, right? Now, remember, if I were to say something like 3x squared plus 4x, this is not 7x squared or 7x or 7x cubed or anything. It's only when it's the same variable and it goes to the same power. So let's remember that because it's kind of similar to I, how we're thinking about I. Even though I is the square root of -1, if you had 4 square root -1 plus 6 square root -1, you would say that this is 10 square root -1, right? That's how radicals work as well. So you almost want to be thinking about it like that when we're looking at these, okay? Let's box this off. Bad line. Sorry. Okay. So the first one we're looking at is 2i plus 6i. Like I said, these i's are the same. They're to the same power of 1, right? So all you have to do here is 2 plus 6 is 8i. Okay? So 4i minus i. Now remember, this isn't just I, this is 1 times I, right? So this is 4i minus 1i. So it'll be 3i. I want you to try the next two, just the next two on your own. It'll give you about, this might be hard to see, but this one has a negative in it. It'll give you about, you could either pause the video or I'm about to give about 3 seconds to do this. 3 to 5 seconds. Okay, so whether you pause or you've already done it, I'm going to go on and keep going with this. So 6 minus 11 is -5. They're both I. This is I. Remember, we can have a negative number here because negative number is an integer and an integer is a real number. So this is allowed. So next you see -7 plus 7. So this is going to get you 0i, which we have not talked about. This equals 0. So let's think about that. What does that mean? That means technically the number 0 is always also an imaginary number because this is a real number. This is a real number times I, and you can see it equals 0. So 0 actually is in the imaginary number, number system, I should say. Now we're looking at this next one. If you guys remember how to distribute, this is a distributing property, right? So we're going to get 12i, because we're doing 12 times I. They're doing 12 times 2i. We get 24i. And now this is equal to 36i. It's a pretty bigger imaginary number than we've seen, but still an imaginary number. Real number 36i. So this next one's kind of funky because we have I squared plus 3i. So there's actually 2 ways that you could go about doing this. Like I said earlier, I squared still works. You could still use these two because they're both I and they're both to the same power. It'd be the same thing as if we had 3x, or if we had x squared plus x squared, right? So we could just say, okay, this is 4i squared. But if you remember from the lesson before, I squared actually has a special meaning to us because it's, or a special, meaning to us because it's -1, or the square root of -1 squared. So this cancels out, and I squared equals -1. So now we have this is equal to 4 times -1, so this is actually equal to -4. Now the other way we could have done this is we could have just said, okay, that's I squared, so that's -1, plus 3 times -1. So we have this is equal to -1 minus 3, which is equal to -4. So now we're looking at this next one, and you can see that we have 20I squared minus 24I squared. So now once again, we could either say, okay, this is -4. This is -4I squared, which is going to be, here, I'll write it out for you. This is -4I squared, which is going to equal -4 times -1, which equals 4, right? Or we could have done it this way. We could say that this equals 20 times -1 minus 24 times -1. Then we say this is -20 minus -24, right? Because we're still in this parentheses here. We're still got to think of this parentheses here, which is actually plus 24. So you would be, once again, get -20 plus 24, and you'd get 4 as your answer. So either way, you're going to get the answer, but there's just two different ways you could look at using I squared. So now let's look at some multiplying and dividing. Bear with me, this is folded down. I don't even know if it's noticeable, but so first we're given I times I. These aren't x's, these are multiplication signs. And this is going to get us I squared, right? I plus I would get us 2I. I times I is I squared. Well, this equals, like we said, -1. So I times I equals -1. Here we have 5I times 3I. It's the same as if you were doing 2x times 3x, right? They're both, or I should say 5x times 3x. They're both the same unit, and they're both to the same power of 1. So here we could just say that this is 5 times 3 is 15, I squared. So this actually equals -15. Here we have -3I times 4I. So we're given -12I squared, which equals +12, because 12 times -1 is +12. I want you to try to do just the next one on your own. -7I times -5I. I'll give you 3 to 5 seconds, or you could just pause the video and wait a little bit. Okay, -7 times -5 is 35. And then once again we have I squared, I times I. So this is going to be -35, because we're doing 35 times -1, which is represented by I squared. Here's a little bit of a different one. We got I squared times I squared. Okay? So I would recommend when you see something like this to instantly change this to -1 times -1. And this will get you +1. But if you want to stay at it, you could say, okay, I squared times I squared is I to the 4th. Okay? So remember, I equals the square root of -1. If you take it to the 4th, it means you're doing the square root of -1 times the square root of -1 times the square root of -1 times the square root of -1. So what you're going to end up getting is simply, you're going to just get 1 by itself. So isn't negative 1, because you're going to end up doing, it's basically a negative 1 times a negative 1 as we see here. So I to the 4th is actually positive 1. So here we see it again. We could say that this is 8I to the 4th, which is then equal just to 8, because it's 8 times 1. I'll do it the other way for you guys too. Here this changes to negative 1, so you get negative 4 times, this changes to negative 2, so you get negative 2. Negative times negative is a positive. Negative 4 times negative 2 is 8. And you're all set. So that's some multiplication. Let's look at some more. Let's look at some dividing, and then we're going to look at radicals as well. So this one's kind of tricky. You're doing 8I divided by 2I. So first off, we know it's going to be 4. But it's not going to be 4I. Because when you do I divided by I, that's 1. Anything over itself is going to be 1. So this is just this is just 4 times 1, so this is 4. So this one's good. Now this one's different, because you're doing 10I squared divided by 5I. So first we know we're going to have a 2, because 10 divided by 5 is 2. Now, when it comes to dividing exponents, right? This is an exponent. 2 is an exponent. This has an exponent 1. What you do is you do I2 minus 1, right? Just like you would with any other variable like x or y or a. This is still able to be divided. You're taking 1I out of I squared. And remember, I squared is I times I. So you're dividing 1I out of there, and you have 1I left, okay? So this is going to equal 2I to the 1, which simply just equals the imaginary number 2I. Okay, I hope that's clear. Now, here, we're given 12I squared over 3. So this has no I in the bottom. So we know that we're not going to be getting rid of this I squared at all. And then once again, 12 divided by 3 is 4. Well, I squared is negative 1, like we've said. So this is 4 times negative 1. So this equals negative 4. Now let's look at some radicals. So radicand here is negative 25. We already actually did this one in the last lesson. And we know that this is a perfect square, 25. So we have 5I. Because another way you could break this down actually is the square root of 25 times negative 1. So right here we see our 25 can cancel out and equal 5. And the square root of negative 1 now is I. So we're left with 5I. So the square root of negative 25 is 5I. All right, now let's look at the next one. So you're going to do 4 times the square root of negative 32. So we already know that there's going to be an I in there because this is a negative number under radical. The next thing we got to do is, okay, break down 32. Now, you might think away 8 times 4. 4 is going to be our perfect square. But think higher. We could also get 16 from 32. Because 16 times 2 is 32. So what we're going to have here, I'm going to erase this I real quick just to make this a little more easy to follow. Under this is we're going to have negative 1 times 16 times 2, right? Negative 1 times 16 is negative 16, times 2 is negative 32. So we're still all good here. Now we're going to take out the I here, and we're going to take out the perfect square here. And this equals 4 times 4I square root of 2. Because the 2 still left over in there. Negative 1 has came out. 16 has come out. These two radicands come out, 2 still in there. Now, all you have to do is just multiply 4 times 4 here, and this is going to end up equaling 16I root 2. So 4 times the square root of negative 32 is going to be 16I root 2. All right? I want you to try the next 2 on your own. Just the next 2. We'll go over the last one together. I'm going to give you 3 to 5 seconds to try to do them, but pause the video so you have more time. Okay. So, we could break this down into negative 1 times 81, right? And 81 is already a perfect square. I don't know if you noticed that, but 81 is already a perfect square because 9 times 9 equals 81. But we take out our negative 1 and we have I. Then we take out the 81 and we have 9I. So this is a nice imaginary number of 9I. Okay, now for negative 20, this could break down into negative 1 times 5 times 4. And there's our perfect square of 4. There's no number less than 20 that is perfect square that could be multiplied to itself, or that could be multiplied to get to 20. That's useful here. 9 times nothing is 20. 16 times nothing is 20, right? But 4 is. So here, we get rid of the 4, and that's going to be equal to 2. All right, square root of 4 is 2. And then we get rid of the negative 1, square root of negative 1, I should say. That's I. So we're left with 2I square root of 5. Now, if you remember from the last lesson, quick random review here. What kind of number is what kind of number is root 5? Root 5, if you remember, is irrational because there's no fraction that you're going to be able to represent the square root of 5. What kind of number is all of this, though? Well, since 2 times root 5 is still a real number, it's just irrational. 2 times root 5 times I is an imaginary number because it's a real number times I. All right, this last one's a little different. So we start with 6I, and then we could break down this negative 72 into negative 1 times what? Now, we already have done this before. Don't think 9 right away. Think higher. You could think higher than 9. Because 9 times 8 is 72, yes. But what if we thought about 36 times 2? 36 is a perfect square, right? So what we're going to be given here is 6I times I, because that's where our square root of negative 1 comes out, times 6 times the square root of 2. So this is going to equal 6I squared times 6. So this is 36I squared root 2. Now remember, I squared is negative 1. So we have negative 36, because negative 1 times 36 is negative 36, root 2. And that is the simplest form of 6I times the square root of negative 72. Okay, once again, as you can see if you printed out the notes, you do not have to be printing out these notes. You could be following along in your own notebook. I understand that when you print these, it gives more of a gray coating over it due to the way that I set up the PDF. This is the same with the homework, so you could do the homework in your notes. But as you can see, some of these take a little bit of work. So I want you showing all of your work when it comes to solving the problems on the homework. All right? Good luck, guys.